Okay, guys, so here's a guide video for free response question 9. And just a moment. Okay, so the rate at which rainwater flows into a drain pipe is modeled by the function r, where r of t equals 20 sine t squared over 35. So that's the rate at which water flows into a drain pipe. All right, so this I'm going to label rate in cubic feet per hour. T is measured in hours, and it is between 0 and 8. The pipe is partially blocked, allowing water to drain out the other end of the pipe at a rate modeled by this cubic feet per hour for 0 to 8 hours. There are 30 cubic feet of water in the pipe at time t equals 0. So this guy's here, that's the rate out. And there are 30 cubic feet of water in the pipe at time t equals 0. So I'll use A to represent the amount of water in the pipe. So A of 0 is 30. Okay, so part A, how many cubic feet of rainwater flow into the pipe during the 8-hour time interval between 0 to 8? So this is part A. How many cubic feet of rainwater flow into the pipe? So the amount in is the integral of the rate in. So, yeah, so the answer is going to be the integral from 0 to 8 and then r of t, dt. And then we got to use our calculator. I got to be in radians. Okay, math 9, 0 to 8. 20 sine x squared over 35 dx. Okay, 76.570. 76.570. This is, yeah, feet cubed. Cubic feet, or you could also say feet cubed if you want. All right, that's for part A. Oh, and I want to tell you how many points everything is worth. Okay, so just for doing that, oh shoot, where did I even put it? Sorry, guys. Huh. Here it is. No, it's not. Okay, shoot, I forgot how much that was. I don't know what I did with, here it is. Okay, that is 2 points. All right, so right there, that is 2 points. 2 points. All right, just for doing that. Okay, now for part B, is the amount of water in the pipe increasing or decreasing at time t equals 3 hours? Give a reason for your answer. Okay, so what you want to do, guys, is you want to see if the rate of change is positive or negative, the rate of change of the amount of water in the tank. So I'm going to go like this. I'll say let A of t equal the amount, in the pipe, the amount of water in the pipe, okay? Then A prime of t is going to be the rate in minus the rate out. So R of t minus D of t. All right, so I've got to see if this is positive or negative, and then that's going to tell me if the amount of water in the pipe is increasing or decreasing. So A prime of 3 is R of 3 minus D of 3. And I've got to type this into the calculator. Okay, so R is 20 sine of 9 over 35 minus, now I'm going to need parentheses because I'm subtracting the whole thing, minus negative 0.04 times 3 to the third plus 0.4 times 3 squared plus 0.96 times 3. Okay, so there's A prime of 3. So this is negative 0.314, which is less than 0. So the answer is decreasing because A prime of 3, which is equal to R of 3 minus D of 3, is less than 0. Okay, that is another 2 points. That is another 2 points. Okay, now part C, I'm going to need room. Right, A, B, yeah, let me just move to a different piece of paper. All right, so for part C, this is 3 points, this part. Right, part C. At what time between 0 and 8 is the amount of water in the pipe at a minimum justify your answer? So this is part C, and we're going to need the candidate's test for absolute extrema. Okay, so I'm going to need to go like this. T A of T. Remember, I let A of T be the amount of water in the tank. 0 to 8. And then in between here, well, that was a bad squiggly. In between here, I need the critical numbers, and that's going to be where A prime of T equals 0. All right, now off to the side, let me define A of T. All right, so A of T is going to be A of 0, because I know that, plus the integral from 0 to T, A prime of W, dW. Okay. So A of T is equal to, A of 0 is 30. 30 plus the integral from 0 to T, and then A prime is R of W minus D of W. Okay. So, yeah, critical numbers where A prime of T equals 0. All right. So what I've got to do, guys, is I've got to take A prime of T, which is R of T minus D of T. So, so I'll say R of T minus D of T equals 0. And I got to type it into my calculator. And you should be doing all of this like at your own pace as well. So 20 sine b squared over 35 minus, in parentheses, negative 0.04 cubed plus 0.4 plus 0.96. Okay, and now I only care about where this is 0 on the interval 0 to 8. So I'll go to my window, I'll make sure my leftmost x, that's x min, is 0, rightmost x, x max is 8, and I'll just start with my y's from negative 10 to 10, and then if I can't see it clearly, I'll fix that. But I graph, okay. Oh, thank goodness. So we only have 1 0. It's happening right there. So I'll go to 0. Okay, so right there, 3.271, all right, so I'll write it here. 3.2716584. And I'm going to store it as, I'm already using capital A, so I'll store it as B. So I go back to my home screen, I hit X, and then I store that as B. Okay. Alrighty, now at 0, we already know that A of 0 is 30. We already know that. Okay, now for this one, A of B at this time, I've got to go 30 plus the integral from 0 to B. And then in here, I could say, I could put A prime, or I could put, I don't know, I'll put this. Okay, and I'll figure that out in a minute. And then here, I'm going to do 30 plus the integral from 0 to 8. Okay, so I got to use math 9. All right, so 30 plus math 9 from 0 to B. And then I've got to do R 20 sine minus negative, so parentheses, negative to the third plus 0.4 okay. Alrighty. This is 27.964569. And then for this one, I could just hit second enter, and that'll come up again. And then I just want an 8 instead of a B. 8. 48.5, okay, 48, 5, 4, 3, 6, 8, 6, 2, 8. Alrighty, they want, at what time is the amount of water in the pipe at a minimum? Okay, so minimum, so min amount of water in pipe at T equals, so this is the smallest of the 3 outputs, so at this time, 3.272 hours. Okay, guys, that whole thing is 3 points. Alrighty, now for part D. This one is 2 points. All right, so for part D. Okay, so the pipe can hold 50 cubic feet of water before overflowing. For T greater than 8, water continues to flow into and out of the pipe at the given rates until the pipe begins to overflow. Write, but do not solve, an equation involving one or more integrals that gives the time W when the pipe will begin to overflow. Okay. Oh boy, this is kind of tricky right here, because I use W usually for the input, or I usually use W for this, but W is the time. So it's going to have to be like up there. So, yeah. All right. So want, all right. So I'll put here. So want A of W, I guess, to equal 50. That's what I want. So I'm going to do, yeah, so I already have, so I want A of W. So I'm going to be using this, or I'll use R of R and D, I'll use that one. So I'm gonna be using this here, but since W is going in for T, W is gonna be up there, so I'm gonna have to switch this to like, I could switch it to T's or X's, but that's funny because I use W in this formula because rarely they use W. Rarely do they use W. So it's gonna be 30 plus the integral from 0 to W, and then in here I'll just say, I'll say R of, I could use T's, I'll use X's, I guess, it doesn't matter. Just as long as it's not W. R of X minus D of X, and then dx equals 50. All right, so there it is. And that's 2 points right there. 2 points for that. Okay.